And welcome. Today we are going to talk about arrays. Let's go ahead and create a new Jupyter notebook. Let's name it P5 arrays, and this will be part 1. Tomorrow I'll post part 2. Okay, now arrays is a object of a library Numpy, and Numpy is this Numpy, and let's make this markdown. Okay, so it's a very important object, and as you may already know, it's all the metrics calculations are performed using this particular object called arrays. And to start working with arrays, we have to use a library Numpy, and so we have to import it. Now to import any library in Python, we have to type import numpy as np and then shift enter. That will run that line. So now we can go ahead and create our first array. So let's first create a one-dimensional array. Now before we move further, to create a markdown for a cell, there's an easy way. So if you realize that when you have the cursor inside the cell, it's highlighted green, and when you click outside the box, it's highlighted blue. So when it's blue, if you press the key M on your keyboard, it will make it a markdown. So let's go ahead and create a heading. This is a one-dimensional array, and I'm going to create a few cells. So let's assign array to a variable x. We have x is equal to np.array, and then we call that function, and in here with open square brackets 1 2 3 and x. So this is array, and as you may remember from the previous video where we created a list was simply written as 1 2 3, and that was list, whereas array is written np.array. And if we want to check the type, we can do that. So if you look at type of x, and again here if you look at print type of x, we can see that this is a class array and this is a class list. Now similarly, as in case of the list, in arrays also the indexing works the same way in one-dimensional array. So if we pull the element at index 0, we'll get 1, because the indexing again start with 0, then 1, and then 2. And for here at index 2, we should get 3. So that's what we get. Now moving on to the next item, which is two-dimensional arrays. So let's create two-dimensional arrays, and I'm going to make this markdown by pressing M on the keyboard when it's highlighted blue. Now for two-dimensional array, it's the same method, but we have to type 2 square brackets inside 1 square bracket. So it's like this np.array, and you have this, and 1 2, and then we have the second one 3 4. So this we can do print type x, and we can also get the shape of x as well as the. So here as you can see, this is okay. Let's type this right here, print x. Okay, so this is an array, as you can see the type, and then it's a two-dimensional array. So it has 2 axes. This is row, this is column, and we can see There are 2 rows and 2 columns in this array. Now to explain the axis better, let's look at one figure. And here we can see in center the blue letters, the greenish blue letters from 1 to 12. These are this is an array, all of these. And on the right hand side, the left hand side, these are the indices for the rows, and these are the indices for the columns. And by convention in NumPy, the axis 0 is this way, pointing downwards, and the axis 1 goes from left to right, goes horizontally. So if in the coming code in this lecture, you'll see that we'll be writing axis is equal to 0 or axis is equal to 1. What that tells us is which axis we are going to perform the operation on. For example, if we are doing a sum, but to do a sum in NumPy, this is how you write it: np.sum open parenthesis x comma axis. Axis, if you put axis 0, what this tells Python is do something. So here's the something would be sum, so do the sum row wise for each column. So the sum would be like this. So the first column is total to 15, second is 18, third is 21, and so on and so forth, 24. And similarly, if we do the np.sum for x for axis 1, then here we are looking at this axis, so do sum column wise for each row, and so this is what we are looking at. So the total of 1 2 3 4 is 10, then the second is 26, and the third row is 42. It's very important to understand the axes in for these arrays, because the indices on these axes, the dimensions, play a very crucial role in future when we get into more complicated matrices and matrix manipulations. Here another point that we need to note is the size of an array, which starts at 0, 0, 1, 2 and 3. So there are 3 rows. So first number is always number of rows, and the second number is number of columns. So here we have 1 2 3 4 columns, so therefore the size of this 2-dimensional array is 3 by 4. Now going back to this example, we can see that if we do the sum for this particular array, we should get, when we put axis is equal to 0, we should get an output which is an array, and the elements of that array would be 1 plus 3 4 and 2 plus 4 6. Let's try that. np.sum x, and let's put axis 0. This will give 4 6 as we expected. And similarly, now if we put the axis as 1, then we will get 1 plus 2 3 and 3 plus 4 7. So we should get 3 and 7 for this one. So let's read that. So that's what we get. And based on this, there are several other ones. If you do not understand, or if this is confusing, I would suggest going back to this image and kind of spending some time on it to understand exactly how indices work and how the axis is used in NumPy, because this is a very, very important part of arrays, and we'll be building upon that now. There are other methods of creating arrays, so let's look at those. Create arrays, and these are standard inbuilt arrays which we would have to use sometimes to initialize an array of a known dimension. These are the kind of methods that we will be using. So the first one is np.zeros, and the way you want to write that is np.zeros open parenthesis and then second open parenthesis 2, 2, and then close both the parentheses. So for this argument np.zeros, we have to supply it with a tuple. A tuple in Python is just numbers in a parenthesis. So if you look at this, type 2 by 2 type 2 by 2 by 2, and that's a tuple. So that's and the difference between a list and a tuple is tuple cannot be edited, it's fixed. Okay, so let's go back here. Let's delete this, go back here. Now when we initialize an array with zeros, by default, as you can see here, it is initialized as float, and we can check that by printing the type. Now if you remember, previously we used type of x to print the type, but what that does is it gives the type of the outer object, and if we need information deeper, one level deeper, we need to use d type. So that will give us the type of the elements that are inside that particular array. And sorry, this has to be x.dtype. Okay, and as you can see, the class is array, which is x, that is correct, and then this is float 64. Now if the array needs to be an integer, we can go ahead and explicitly specify the d type as int 64. So what that does is it will create an array where the class is array and the d type is data type is integer 64, and you will notice that the decimal after the zeros is now not there. Similarly, we can create other types of initializations for arrays. This is np.ones. Again, it takes a tuple to create the array. So np.ones, and similarly we can have np.full. Now in np.full, there is a option we can specify a number that needs to be there in the entire array. So let's say if you want to put 10 there, that's how this array will look. Next up, we have we can also create a random array. So np.random.random, and for this again we need to supply a tuple. So 2 by 2, and there, that's the, now because this is a random array, if we if we run this cell again, we'll get different number each time. However, if we put the seed is equal to 1, I think, is that the way it works? No. Okay, never mind. Seed is equal to 1. No. Okay. So that's the random array. After random array, there are two more important arrays, which are two important methods by which we can initialize an array. One is a range, that is a range. Sorry. So np.a range, and the way this works, we have to give a start position. You have to give a start, a stop, and a step. You have to give minimum 3 information. Not minimum, but we have to give 3 information. It works on these 3. And the other is linspace, and this one has start, stop, and number. so how many repeats we want. And if you want to look at more information on any of these functions in Jupyter Notebook, there is a easy way to do that. So you do not have to memorize all this syntax. And to get the actual syntax, what you can do is type a range and then put question mark and then run that cell. So here you go, you get nice description of what the syntax should be, and you get a description of the input variables for that function, as well as you get an example below as how to implement that particular function. So this is really handy and I use it quite often. Now let's try to create an array here. So np.arange, if we go from 0 to 10 and let's say with step of 1, we get 0 to 9. Now similarly, if we create an array with np.linspace from 0 to 10 with if we need 10 repeats, 10 elements in there, this is how it will look. 0 1 2 3 4 5 6 7 8 9, sorry, so there's 10 elements starting from 0. Here also there is an option to specify d type. So if you put d type is equal to int 64, then you get the integer there, and if you specify that here int 64, then you get the integer values here as well. Now you'll notice that here that all these are evenly spaced except this last part which goes from 8 to 10 instead of 9, and the reason for that is there is another option here that we need to set it to false. So if you type linspace question mark and run that, this is the endpoint is what we need to set to false. So I'm going to close this and type endpoint is equal to false, and now we get the exact same output from both of those. Okay, next moving on to slicing. Let's create another heading and make it markdown. Now slicing again is extremely important. The correct way to slice a data is very important, because in matrix manipulations sometimes you'll have a big array, and based on that you'll have to extract information from that array to either do some calculations or create new arrays based off of the original array. And slicing is similar to what we did in lists before, where the indices start with 0 and move forward. The only difference in arrays is that if it's two-dimensional array, as we saw in this figure, we have to specify the indices for both the axis 1, axis 0 and axis 1 both, and I'll show how that can be done. So let's go ahead and create an array here. This is going to two-dimensional array 1 2 3 4. Let's create exactly same array here, 5 6 7 8, and then 9 10 11 12 x star x. Okay, so this is our array. Now if we are looking to extract a subset of this array such that we want all the rows but only columns with indices 1 2 and 3, so we just need this column, this column, this column, and all the rows. So to do that we have to specify x open bracket. Because we need all the rows, we just put a colon there and then comma. For the columns this is column 0 in at index 0, so the index for this column is 1. We start with 1 colon, and then we need all the columns after that. So if you leave it blank, Python knows that it has to take all the columns after that. So this should give us exactly that. Now if we were to find, if we need a subset of this array which has only this 6, 7, 10 and 11, to get that part, this is how you would do it. First we need the indices for this one. So the row is 0, 1, index 1 and colon, and the index for this one is 2, so plus 1, 3, because we know that it excludes the last index, so it's before that index, so before 2. So 0, 1, 2, sorry, this is 2, so before 2 plus 1, so that has to be 3. And similarly on the columns we have 0, 1, I start with 1, and oops, sorry, okay, 0, 1, and then this is again 2, so plus 1, 3, and therefore we need that 3 there. This is how we get that particular subset, so these two and these two in the subset array. And additionally, there's one important part to remember in this particular case is when we did subset the lists, when we change the subset of a list, it does not, or it did not change the original list. So for example, when in the case of lists, when we had x is equal to say 1, 2, 3, and we when we changed x, so let's print x here before, okay, and now if we go ahead and change the value of, now if we get y, the value of x, let's get 0 and 1 from x, sorry, 0 to 1, and now if we print y, and now after that if we print x again, and this could be 0 to 2, and then we change y, so we are pulling, so here we are pulling just the first 2 elements of that list, and then we want to change the very first element of this to 1000. Now as you can see, when we updated the value for y, which is the subset of that list, it did not change the value in the original list x. However, when dealing with arrays, that's not the case. So in arrays, so let's take the exact same example, and here we'll convert this to an array, np.array, and that, and then again np.array. This is already good. So here, as you can see, before the value for x was 1, 2, 3, but afterwards when we change the value of the subset of x to 1000, that value actually changed the original array. What that tells us is that when we are subsetting an array, we are not actually creating a new copy of that array, we are only creating a new reference to the same array. Therefore any changes to the subset immediately affects the original array. And to avoid this, there is one way we want to do is explicitly make sure that it's a copy, and to do that we just have to type in np.copy in front of this, and now as you can see, because that was a copy, Python knew that it had to create a separate array of that subset with a new reference, and it had nothing to do with the original value of x, and therefore when we change the value of that subset, which was by itself, it did not change the value for x. Okay, so after this, let's look at a few more methods of getting subsets or extracting data from arrays. I'm going to copy this one back down. Okay. Now here we can earlier we used slicing to get the arrays, get the subsets. We can also use indices of these arrays to get the subsets, and the way that works is, let's see, using indices to get subsets. Okay, let's try this. Now from this array, let's move, okay, x. Now here, if we, the beauty of using indices is that we can create an arbitrary array, and we can pick information from the original array from any location and put them in a completely new array. So it does not have to be a of the same type, it does not have to be a subset. It can be complete, it can be a one-dimensional array, or it can have more of the same elements in the same array. So let's say if we create another one here, y is equal to x, and because this is a two-dimensional array, in here we need two square brackets. Now if we want to pick 1, we know that the index it's at row index 0 and column index 0, so we put row index 0 here first, column index 0 here second. Next, let's say if we want to pull 9, it's at row index 2 and column index 0. Next, if you want to pull 7, it's at row index 1 and column index 2. Okay, so now when we print this array, we will get a one-dimensional array that has three elements, which is 1, 9 and 7. Sorry, there has to be a square bracket there. Okay, 1, 9 and 7. Now similarly, we can do additional we can do a combination of these indices as well as the slicing technique. For example, we can create another array here where, let's say we want to pull the element at index 1, and then we want to pull from 2 to 3 and y. So as you can see, we got an array which is 7, which is the number 7 here, but then when we look at the shape of that, so if we print y.shape, we can see that the shape is 1 comma blank, and that's because we are combining index method with the subset slicing method to get extract data from the same array, and therefore it's like this. If we wanted to get 1 1, we would have to write the slicing, complete slicing, and that would be we are at index 1 to 2, and the second one is 2 to 3. Here now if we print y dot shape and then print y, we get 1 1. So this is important to note that the 1 1 in the shape is 1 1. This is important because I'd suggest when slicing any information from an array, using only slicing and not mixing them, because in future videos you'll see that if there are multiple matrix manipulations where sometimes you get stuck because you cannot do a dot product between two matrices, and the reason is because they do not align. One matrix is 2 by 3 and the other matrix is supposed to start with 3 rows, but instead you have 4 rows for some reason. And to find that bug, you have to go back and look into previous arrays which led to those two misaligned arrays, and in those cases having the having this notation helps a lot to kind of troubleshoot faster. Okay, after that, the second point I wanted to show is using indexing again. As we saw here, we can also use indexing to create an array from an array. So for example, if we create an array of index, so let's say we create an array of index here, np.array, and this could be 0 1 0 1 2, and we create another array, np.array, that is say 1 1 1 2 0. And now if you go in here for x, and if you pull the information for m and n, get this particular array. So let's put x here again. As you can see, the 2 has indices 0, row 0, column with index 1. 7 has row 1, column 2, and 9 has row 2, column 0. So that's another way where you can create arrays of indices that can be used to pull information from existing arrays. Next, after this, let's talk about array mathematics. So we can use the common operators that we usually use in performing mathematical operations right here. So let's try that. The first one, let's create two simple arrays. X is equal to np.array 1 2, and then let's create another one, np.array 3 4, and let's create another one, np.array 10 or let's say 5 6, and then another one 7 8. Okay, so we can go ahead and print x, and then we can go ahead and print y. Okay, so the mistake was we forgot the square brackets there. Okay, so we have x and y. Now to do an addition, we can simply do x plus y, or so let's say print x plus y, or we can say or we can do, let's do x plus y is that, or we can say np dot add x plus y. So both of them work just fine. Sorry, x comma y. Similarly for subtraction, so subtract, it can be x minus y, so print x minus y, or we can have np dot subtract x comma y. So both work the same way. Next, if we need to multiply, again it's the same way. You can do x, either x y, or you can do np dot multiply x comma y. So both work same way. And then we have division, so say divide x backslash y, or it could be np dot divide x comma y, and we get the same. It's the same answer there. Apart from this, we can also pull the minimum and maximum number, or minimum and maximum, the index of the minimum and maximum element within an array. So let's go back and take this one. Now here, if we want to pull the minimum, let's try that, and that's wrong. np.min. Okay, so we know that from the entire array the minimum is 1. Now we can get the minimum by using axis command. So when we use 0, it means we are trying to get minimum row wise for each column. So we are going to look at the minimum in this column, minimum in this column, third, and so on and so forth. So here we should get 1, which is smallest in this column, 2, 3, and 4 is the smallest in the last column. So the final output will be 1, 2, 3, 4. Similarly, we can get max, np.max x axis is equal to 0, and here we get the last row because it is the maximum. And now here, if we replace this 0 by 1, now we'll get the operation would be, we are trying to get the minimum of the elements column wise for each row. So we are working horizontally in this particular case. So the minimum here is 1 and the index for that is 0. So here when we run this, we get 1, 5, and 9, which is the smallest, and with 4, 8, and 12, that's the largest number. Interestingly, in addition to min, there is another command which is really helpful, which is called argmin. What argmin does is it locates the minimum number and then returns the index for that particular element based on the axis that you have given. So if you say argmin axis is equal to 1, then we get that index is 0. So obviously these are all at index 0 because these are all the minimum numbers for all those rows. Similarly, we can get argmax for all the we can get argmax, which is the index for the maximum number, and there you go, we get the 3 because these are the 3 maximum numbers in each of those rows. Likewise, if you change this to 0, you will get the indices for minimum and maximum element in each column row wise. If this is still confusing, I'd suggest going back to this figure and trying to understand how the axes work, how the indices work, and kind of practicing it a little bit to get it straight, because If there is confusion on this part, then it becomes a big problem later on. So it's important to clarify this particular figure very clearly right now. Now, before closing this lecture, I just want to share one more command, which is square root. To get the square root, and this is element-wise square root, so say sqrt and x, and so this will be element-wise square root for all the numbers inside that array. There is also element-wise addition, subtraction, which we all saw here. This is all element-wise because we are multiplying. So here 1 plus 5 is 6, 1 plus 5 is 6, so we are performing the arithmetic on individual numbers at those exact same indices. Apart from that, I'll go into more detail in the next video. If we need to take dot product, then the notation is np dot. So if you want a dot product, so this will give a dot product for both the matrices. Now, as you can see here, we cannot use those two because they are misaligned. The array x is 3 by 4 and the array y is 2 by 2. So we need an array where this matches with the columns, number of columns in one matrix matches with the number of rows in the other matrix. So in this case, let's try to create another matrix. Let's say x is equal to np dot array, and here we can give it 1 2, and then let's call this 3 4, and similarly we have y, which is np dot array, and he will make this. Let's go ahead and just copy this for now. I think you get the point. So here you go. So this is a dot product, which is completely different than this, which is np dot multiply xy. So that's element wise product, and the other one is dot product. Okay, this is all for today. I hope you enjoyed the lecture. Tomorrow I'll be uploading a new series, which is part 2 of today's lecture, and in that I'll be covering additional topics such as joining the arrays, then splitting the arrays, and reshaping the arrays. So those are also very important topics that you have to know to get into more advanced topics. Okay, thank you.